Coming to Mr. Sameer Singh now, representing stainless steel, Jindal Stainless in Odisha and Haryana. So from a steel making, core steel making technology, and then a little bit of niche into stainless steel making, what are the broad challenges in terms of adopting greener technologies within a stainless steel plants? And again, the question, as I asked Manish earlier, that from a cost pressure perspective, because we are seeing ferrochrome being imported to India as well. So you need to be competitive in the marketplace, even though there could be good demand looking into the next 5 to 10 years of stainless steel. At the same time, if you need to adopt these green technologies, which is delta additional cost, how are we managing the so between the two?
Sure. Great question. Thanks, Bidyut. Okay, so I'll begin with some context, right? So I represent the stainless steel industry. Stainless steel is slightly different, at least in India, when it comes to manufacturing. We are essentially secondary steel makers because we manufacture stainless steel through the scrap electric arc furnace route. What is virgin? The virgin material that we use is our ferroalloys, which is a point that I will delve upon in some detail at a later stage. Now, coming to decarbonization in general for the steel industry, the way I see it, it's a strategic issue, right? Because when we set up capacity, and given that India has an increasing capacity and we're targeting 300 million tons by 2030, we have to make strategic decisions for the next 50 years, 80 years of operation, right? Given that most of the alternatives when it comes to green steel or low emission steel manufacturing options out there, these are at TRL levels that are not high enough for manufacturers to understand whether that is the way forward. So when we chart out a decarbonization roadmap, what we talk about is pathways. It is the pathway question that's where we sort of get stuck up at. For example, while I was in consulting, I did one of an assessment for a steel major in India. Essentially, the question was, how do we proceed? We have so many options. We're locking in money for the long term. Where do we go from here? And I think that's where progress needs to be made. And when I say progress, I mean there needs to be advancement of the TRL levels of certain technological options like green hydrogen DRI route, etc., so that the industry can arrive at a pathway that then becomes favorable for the particular situation they are in, right? Now, this is for the steel industry in general. Now, when I talk about stainless steel industry, and I'm going to sort of give the perspective from Jindal Stainless manufacturing units, we manufacture stainless steel from scrap, right? And as you would know, scrap is not available in India in not even close to the amounts that we need, right? And that's going to be a perennial problem in any industry that's growing, because your scrap availability at best is going to be the steel you produced 30 years ago, if it's carbon steel, and even further back if it is stainless steel, because end of life for stainless steel is slightly longer. Therefore, with this issue, scrap is always going to be a problem. Now, the second thing is our virgin material that we need, which is ferroalloys. Stainless steel is typically around 70 to 80% iron. The remaining materials are my alloying elements, primarily nickel and chromium, right? So when it comes to decarbonization for stainless steel, there are a few things that we focus on. And this is from a secondary steel making perspective. One, wherever we need to reduce a material, a metal. So for example, we need to reduce chromium from chromite ore. We need to reduce nickel from its oxides. And we use iron from our scrap. Therefore, when we talk about our ferroalloy inputs, we take the conventional aspects of emission reduction. Now, when it comes to ferroalloys, it's even more difficult than iron because Hydrogen has been proven to reduce Fe2O3, but it does not work for chromium. It does not work for nickel. So the way it has evolved, and specifically in the European region, our primary competitors in stainless steel making reside in Europe. They have taken to the biomass route, at least for the ferroalloys, right? So, but then that is based on the particular fitment of the geography, which is may not be suitable for us. So that's one way. So biomass would be our prime sort of lever for ferroalloy reduction. Second, obviously, given that we are making it from the scrap or recycled sort of route for iron, another important aspect for stainless steel industry when it comes to decarbonization is to increase my recycled content as much as I can. So that would employ us to source as much segregated grade-wise stainless steel scrap as we can, and we employ that in our process. This reduces our dependency on virgin raw materials like nickel and chromium. Third, the most important, since ours is a secondary route of steel making, we are heavily reliant on the electric arc furnace, which essentially is reliant on electrical energy. So renewable energy for us is a much larger lever than it would be for conventional carbon steel industry in India. And that is something that we are doubling down on. And you would have probably heard from a lot of our corporate communications to the external stakeholders that we are heavily invested into renewables. So renewables being one of our major levers. Now coming to scope 3, scope 3 is very essential for us because of course we rely on a lot of materials like ferroalloys, etc., to manufacture our products. So scope 3 becomes important, and which is why identification and assessment of our supply chain and working with them to reduce their scope 1, 2 emission, which will effectively cascade into our scope 3 reduction, is also an important aspect that we are sort of embarking on by engaging to the entire supply chain that we have. So these are essentially the top levers that we are currently exploring. Thanks.